This is an idea I drew up about 8 or 9 years ago in CAD to make a sphericity tester or a roundness tester for a pool ball. So this is the pool ball, and it would sit on top of these three balls, and then you would put an indicator here that would have an arm that comes down and touches the top of the ball. And you would spin the ball in your hands, and you would watch the indicator go up and down and see how out of round it is. This is one example of the type of indicator you could use. And as you see, this moves the needle. And there will be an arm here that holds this about like this. So as you rotate the ball, any variation in the ball roundness would move this up and down. So the idea with this is these three balls I would buy as ball bearings, precision ground, and they would go into pockets in the base that would have a chamfer, so the ball would only touch the chamfer in one spot around the whole circumference. And then on the back side there would be 3 screws going into threaded holes in the ball, and they would pull the ball tight into here. And then these 4 holes were to put rubber feet, and also so I can screw this down to a fixture plate as I'm machining it and put all the features in. So as I said, I drew this 10 years ago, 8 or 9 years ago, and I was going to machine it, and then I just forgot about it, and you know how that goes. And this was my original sketch before I went into CAD. So this is a top view. You can see the 3 balls, and here you can see the 3 balls, and this little point here is the point of the indicator on some sort of column to hold it. And here's a side view. So here's the base, here's the 3 balls, here's the pool ball, here's a column, and here's the indicator. And they also sell things like this. These are good examples. You can get these pretty cheap, $50. So it's a granite block with a post and the indicator. So I could put the stand I'm making, the base, on top of this surface and use this. I just have a bunch of these and I don't want to spend any more money. So I wanted to see if I could make it first, how well it works, and then maybe get one of these. And the original plan was to machine this out of aluminum. Now I have a 3D printer at home, so I'm actually running this on the printer just to see if I have all the spacing right and if I have enough room to put this indicator on it. So there's 3 balls in here. So the snooker ball is there, and then the next is a pool ball. You can see it's a little bit bigger. And the next is a carom ball, a billiard ball, and you can see that's bigger still. So this would work with all 3 of the major ball diameters. Here's the 3D printer. It's going right now. You can see the outline of the base, and it's doing the top of it diagonally. Here's a look at different measuring instruments. Here we have a dial caliper. These are micrometers, micrometer stand. This is a standard. These are test indicators. These are stands for the indicators. And here's a couple pool balls. And these are actually the balls that are going to go inside that base we're printing and will later machine. As you see, I never opened them. I bought these 10 years ago, 8 years ago. And then I also bought this ball. This is the same diameter as a pool ball, 2.250 inches. I got it just to see how accurate the jig was, compared to a pool ball. This is what most people are used to when they see a ball diameter measured. This is called a dial caliper. It also comes in electronic versions and actually a vernier version that doesn't have a dial at all. So these are really handy because they can go through a wide range. This one goes from 0 to 6 inches in seconds. The problem with them is the jaws are cantilevered. So if you measure out here, you might get a slightly different measurement than out here because this jaw rocks very slightly. So here I'll take this 9 ball, and if I measure it at the jaws, at the tips of the jaw here, I get 2.243 inches. And if I go closer, well, the ball diameter is too big, but 2.244. Here is a standard. So this is exactly 2 inches. It's a Starrett standard. So if I put this in here and go back here, you can see I'm about a little bit under 2 inches, about a half a thousandths under. And if I go at the bottom here, well, they measure the same, thousandths under, thousandths under. So this is actually pretty consistent for dial calipers. This is a top brand, Mitutoyo, it's Japanese. But in contrast, here, this is a micrometer. And the measurement is along this axis. So it takes a long time to open and close it, but it's much more precise. This only goes between 0 and 1 inches. So it fully closed is 0, fully open is 1 inches. So to measure a pool ball, you need this one. And this one goes at its smallest is 2 inches, at its biggest is 3 inches. So right now I'll put it at its smallest, so 2 inches, and then I'll put and here you can see, you can't see, there we go, you see how the line lines up with the 0? So if I open it, it goes right to 0. And this has a ratchet. So you put the same torque on it every time and it goes right to 0. So this is more repeatable and more accurate if you're going to measure a pool ball and you want a very close number. And then to make this even easier to use, what we have here, so we have another one. Okay, it's a second one, and it's mounted on a stand. So with this being on a stand, I can hold the ball in one hand and listen for it to click, and then I can rotate the ball, try another spot. So this will allow me a lot more convenience, and it keeps my hand away from this, which makes this warmer and will actually affect the reading if you're trying to be that accurate. In this next group here, we have indicators. So this style here is called a plunge indicator. So it plunges in and out, and this is the same. This is a better brand. And this particular one has a magnetic base, so you can stick it on ferrous metals. And this one here is called a dial test indicator. There you see the needle move. So it moves when I push this down at an angle. So this one has a much smaller range of motion, but its resolution is much higher. Each line on this is 1/2 thousandths of an inch, whereas each line on these two is 1/1000th of an inch. And you can see how much larger, how much further apart these lines are. So this one you can read much more accurately. And I also have another one of these that I don't have here, but it reads 1/10,000th of an inch. So 10 times 1/10 a deviation of this one. Or actually 1/5 a deviation, because this reads 1/2 thou. So that one reads tenths. So on the stand we're making, I may use this type here, and it'll sit on top of the ball. Or I may use this type here, and it'll sit like this. Next over here, we have stands for the indicators. So there are different types of stands, and this one here is meant to slide on a granite plate, and you would mount the indicator like that, or if you're using this one, it would mount like that. And then it has a fine adjustment. This knob here makes the whole thing move up and down very finely. This one here has a magnetic base. This one's really cheap. And it has the indicator will go like this. And this one here also has a magnetic base. And you can see that hole there would go around here, and you can angle this in different orientations. So I already have these. This one and this one's probably 40 years old. Since I already have these, that's why I'm not thinking about buying that granite plate. So I'm going to try to use what I already have that I've had for many years, and see if I can get those to work. And why am I doing all this? Well, I have all these sets of balls. I have Cyclop, Aramith Super Pro, Brunswick Centennial, never opened, Aramith tournament balls, never opened, and this one is Rashig balls, new old stock, and this is a Disney set. And I have a few more sets, and I have another set coming. So I actually bought all these sets to see the difference in them, and because I'm a pool nut and I just like collecting things. And I actually really want to use these sets, but I want to measure them before I hit any balls with them when they're brand new, and then hit balls with them for a while, and then measure them again, see how they hold up over time. So that's why I'm going through all this trouble, one reason. And the second reason is because I'm a mechanical engineer, and I like machining for fun, and I like pool as much as I like machining, probably more. So it's a good mix to do something combining two things I really like. That's it for part one of this video. Part two, this will be done, and I'll test it, see how it works, and I'll see you then. Thanks for watching.